We'll now have a look at how to make the calculation to create lines for linear equations. The first skill that we'll look into is calculating the slope. And what we do, we'll need two sets of points. You can see in these questions the points are highlighted. And we're going to take those two sets of points and we're going to use one equation that helps us calculate slope. Basically the difference in the two y values versus the difference in the two, divided by the difference in the two x values. So we're reading off and we see that our point is right at x equals 0 and y is 4. That's our first point. And our second point is left 2 on the x-axis, the -2 and -1. There it is. And we could actually use either set of points as our first set of points. It doesn't matter, so I'll just go in order and call this one here x1 and y1, and this one here x2 and y2, remembering that the set of points always goes in order, is always x comma y. It's important when we're substituting the values in to make sure that they go in brackets. Watch this. So when we take y2, which is -1, we're going to subtract y1, which is 4, and that's going to go over top of x2, which is -2, and we'll subtract x1, which is 0. If you get negative values over here on this side, if you're substituting negative values in, that will change. The two negative signs will become an addition, and so that's why substituting in brackets can often help you out. We will continue just like this. Okay, so 1 below, and we go down by 4 more. We're at -5, and -2. Subtract 0 is just -2. So there we have -5 over -2, and you might think that the answer is that. But if you look at this fraction here, two negatives would divide out to make a positive. And this one here is claiming that the fraction overall is negative. So those are not the same thing. Instead, another way to write -5 over -2, since you don't see it in any of the answers, would be the two negatives would divide out to be positive, and we end up with 5 over 2. And there it is, answer B. Now another thing to consider, which might have been, so a lot of people would say the easier way to get this result, you can do it any way you want. You can also just count out how much rise versus how much run. So we went up 1, 2, 3, 4, 5. Okay, so we went up 5 for every 1, 2 to the right. And you will notice that that's the same thing as the slope that we calculated. You could also consider that if we start at the top point, if we go left 2, if we go down 5, 1, 2, 3, 4, 5, and left by 2, so down 5, left 2, we end up getting the same result. Just a quick note for questions 12 and 13. These are two special cases. We talked about those in the previous video. So if you need that information, you can go back and look towards the end of the previous video. For this next set of questions, you're actually given the 2 points. You don't even have to read them off the graph. So up here, we read them off the graph. We used slope, or m is equal to y2 minus y1 over x2 minus x1. So you take the 2 points and you use that formula, and that's how you would work out this type of question. Next, we're asked to write the slope-intercept form of the equation of a line. So that means the y equals mx plus b format that we're familiar with now. So there are several ways that we can do this as well. I'll go through one possible example. And if I look at number 17, one thing I notice is that I can see the y-intercept. That happens at -4. And knowing the format of the line and what each of the letters means, that is my b value. So first step, I've got y is equal to mx minus 4. Now if I'm using the graph, I can likely just count out the slope as well just by looking at the line. So as I start from a point such as there at -1, -3, I know I'm going up 1 and left 1, and then I'm going up 1 and left 1 again. So that seems to be the slope. So my rise is up 1, left 1 would be negative, and then I've got x minus 4. So this is pretty much slope-intercept form of the equation. I'd like to clean this up a bit, although it's still correct the way it is. 1 divided by negative 1 is negative 1, and for some reason in math, when it's the number 1, we're allowed to ignore it and not put it there. So you might have negative 1x minus 4. That would be totally correct. This is probably the most mathematically conventional way to write the equation of that line. So now we're trying to do the same thing, just without a graph, just using some information. So what we're given is calculate the slope-intercept equation of the line that has a slope of 1/4. All right, well, we know slope is the m value, so we're calling that 1/4. And the line also passes through a particular point. So the xy value is negative 12, negative 2, where negative 12 is your x value and negative 2 is your y value. So knowing that we're looking for a y equals mx plus b equation, that's slope-intercept form, we know 3 of the 4 pieces of information which will allow us to solve for the y-intercept. And when we're generating this equation, it's just the m and the b values that we need to fill in. We're going to leave x and y as variables. So subbing in minus 2 for y. Slope, we said, was 1/4. The x value is minus 12, and to that we're going to add plus b. And now I'm just going to work on solving this. And so minus 2 on the left is equal to, all right, so 1 times negative 12 is negative 12 divided by 4 is minus 3. And that we add b to, which again is the value that we're solving for. So now we take our negative 3 value, it's going to come to the other side. So basically we're adding 3 to both sides. It disappears on the right and shows up on the left. And there we go, negative 2 add 3 is positive 1 is equal to our b value there. Therefore, our equation, what are we doing? We're filling in the m and the b values. The slope we know was 1/4. X and b is positive 1, and we're done. Same concept in 22 and 23. The difference is that instead of being given the slope, we're now going to have to calculate it. And we did this earlier on. The slope is equal to y2 minus y1 over x2 minus x1. So we have to make that calculation first with the 2 sets of points. Okay, and then from there, we'll do what we did in the previous question. We take the slope and any one of the 2 points, and we will calculate the y-intercept. So let's get started here. The slope itself is y2 is negative 1 minus y1, which is positive 1, divided by x2, which is 0, and subtracting x1, which is minus 5. Here's the place where we get the double negative. That's why I sub in brackets. So we end up with m is equal to, well, minus 1 is negative 2 over top of positive 5. Okay, so negative 2/5 is our slope. We're going to use that information, and we are going to take one of these points that we have, and we're going to calculate the y-intercept. So we're looking for y equals mx plus b. All right, substituting in 1 for y, I'll just use the first point here. And for m, the slope, it's minus 2 over 5. Okay, the x value from the first point is minus 5. And to that, we'll do our plus b. Okay, so negative 2 times negative 5, well, that's going to be negative 10 divided by positive 5 will be minus 2 plus b. And from there, 1 plus 2, as I'm solving this equation, I get that b is equal to 3. Therefore, we've got y is equal to negative 2/5 x, and what was our y-intercept was plus 3. There's the equation of the line. Okay, the last concept here, we're looking at parallel and perpendicular lines. Okay, so we talk about this in class. Any two lines that are parallel are moving in the same direction. So they must have the exact same slope, right? So the slope of the first line must be identical to the slope of the second line. All right, so what the instructions are saying here is calculate a second equation for the line. There's the first one. We're going to calculate a second one. The second one is going to have the same slope, but a different y-intercept. That might make sense if we looked at it something like that over here. Same slopes, different y-intercepts. So we're starting out with some information. We know that our y value, because our new line passes through 3 minus 4, not the original line, the new line. Minus 4 is equal to, well, the same slope, so negative 1/3 of x, which happens to be 3, and the part that we don't know yet is the y-intercept. So that's what we're going to solve for. Minus 4 is equal to, well, 3 times 1/3 is just going to be 1, and it's negative, so negative 1 plus b. Okay, so negative 4 plus 1 is equal to b. b is equal to, better clean that up so you can see what I'm doing here. b is going to be equal to negative 4 plus 1, which is negative 3. Therefore, here's the part that we're looking for, the actual equation of the line. Y is equal to negative 1/3 x minus 3. All right, the very last section of graphing with linear equations, we're going to calculate another slope-intercept equation. This one, though, is not parallel, it's perpendicular. So if we think about a graph and we think about two lines that are perpendicular, if you had one like that and one like that, it means that they meet at exactly 90 degrees. So we know the first equation of the line. We're going to calculate the second one, or at least I'm going to get you started with it. The way that we're going to do that is we need a new slope value. So if the original slope is minus 2, as we see in the question, we need to calculate a perpendicular slope at 90 degrees. So as we talked about in class, that's the negative reciprocal. That's the fancy way of saying we're going to take the slope and we're going to flip the fraction and change its sign. So this here is negative 2 that we're looking at. And it's hard to flip negative 2 because it's not a fraction yet. But any number can be written as a fraction over 1. So there we are. M1, our first slope, is equal to negative 2 over 1. Our second slope is going to be the negative reciprocal. So let me flip the fraction. Instead of 2 over 1, it's 1 over 2. And instead of being negative, it's going to be positive. Okay, here's where you're going to take over because we have a point on the line, 0 and negative 3. So when we're looking for the y equals mx plus b equation, okay, that's the slope-intercept form, we now know our perpendicular slope, and we know a point on the line, 0 for x, minus 3 for y, allows us to solve for b, and allows us to get the final format of the slope-intercept equation.